Today, I just want to quickly go over the practice test with the derivatives, just how we want to approach these problems so we can fix anything that has come up. Let's just kind of go through these. In problem one, we're finding a bunch of derivatives. So in problem one, we just have a polynomial. We're just playing the nx to the n minus 1 game. The whole concept behind this problem was that you can nx to the n minus 1 all the way through. You can nx to the n minus 1 all the way through. You got to be able to read the problem, then nx to the n minus 1. Here you have to do a bunch of nx to the n minus 1. So y is 2x plus 3, or y prime is 2x plus 3. The next one, I said we can nx to the n minus 1, but I wrote 5 square root of x. This problem is a reading problem. I want you to know that the square root of x is a 1/2 power. So in this problem, I'm saying, hey, do you know that a square root of x is a 1/2 power? Now notice that this is just attached to the f of x. This is not us taking a derivative. This is just rewriting a power of x. We're rewriting the radical as a power of x. That's just a rewrite. So we can do the nx to the n minus 1. So our derivative, f prime of x, 5 is a constant, it just carries along. The derivative of x to the 1/2 is a 1/2 x to the minus 1/2. 1/2 minus 1 is minus 1/2. So I'm writing in all the stuff what's going on. And then you can put these together. This was totally acceptable because you nx to the n minus 1. I could see that you read the function, you nx to the n minus 1, everything is cool. If you're like, oh, no, I don't like this, negative exponents. I've been trained to not like negative exponents because, I don't know, sometimes that happens. And also this problem was given to me in radicals, so I'm going to return my answer in radicals. And x to the minus 1/2 is a 1 over x squared. This is important later on, so I'm going to make sure I note that. It's 5 over 2 square roots of x. Or the one in the middle, 5 over 2 x to the 1/2 power. Negative 1/2 in the top, 1/2 in the bottom. Any questions? That first thing, 5x to the 1/2 power, that's just a rewrite. So we can do the nx to the n minus 1, which is what we want to do. The next problem, I've got a 5 over x to the third. In this problem, we're going to do a rewrite again. This is me just asking, what do you do if there's an x in the denominator? We've got to move to nx to the n minus 1. That x has to be in the numerator, so I'm going to do a rewrite on this as well. I'm going to write this as 5x to the negative 3. Now we can nx to the n minus 1. So g prime. The 5 just hangs out, and we multiply by negative 3 x to the, now here's the tricky one. We have to read that negative 3 with a negative 3. So when we subtract 1, we go to negative 4. Negative 3x to the negative 4. First acceptable answer, negative 15x to the negative 4. If you're like, oh, nah, negative exponents, I was trained that these aren't okay. Put that in the denominator, and you can write this as negative 15 over x to the 4. I'm writing all vertical because I have space and I'm just writing out by hand. If I was typing this, I would probably side by side it. Negative 15 / x to the 4. But since at this point we were writing, we'll just stay vertical. In this problem, the idea was that if we can write powers of x, then we should write powers of x. We have 3 terms being divided by 1 term. We'll use the distributive property to rewrite this. Some of you use the quotient rule. That's super excessive. If I was more pedantic than I am, I would have definitely thrown a flag, called a 0-point penalty, excessive use of math. This is what the ref does for excessive use of math for those of you watching the Super Bowl. It's just a loss of time, and the penalty is time spent. I mean, that was just kind of excessive, but that's okay. Some of you wanted to flex away. My intention for this, which is what made this problem sneaky, is that I want to write this as powers of x. So I'm going to distribute the divide by x. X squared over x plus 3x over x minus 4 over x. Then I could just simplify each of these terms. X squared over x is just x. 3x over x is just 3. And I'm going to write this as 4x to the negative 1. So now I've got these terms and I can nx to the n minus 1. So y prime. We still have a derivative. We're just algebra. It's going to be 1 plus 0 plus 4x to the negative 2. Completing in this problem, this fashion is a rare, on the list of achievements on the PS4 version of this test, it'll be like, this would be like a rare achievement. So this is our first acceptable. You could also rewrite that as 1 plus 4 over x squared or x squared plus 4 over x squared. For those of you who have x squared minus 4 over x squared, because you did the quotient rule, the minus fg prime, you didn't distribute it to the negative 4. That's why it should be positive 4. 1e. We got capital F is 5 over. Here I was just running out of creativity. And so I did problem 1b and 1c and I just put them together. Algebraically, rewriting this is 5x to the negative 1/2. So now we can nx to the n minus 1 for capital F prime. The 5 is just a constant. The derivative of x to the minus 1/2 is a minus 1/2 x to the minus 3/2. Putting our constants together, we could write this as minus 5/2 x to the negative 3/2. And that'll be our first acceptable. Some of you put the x to the negative 3/2 into the denominator. The important thing to note, if you're going to go back to radicals, it's a square root of x and it's being cubed. The denominator of the exponent is the index of the radical. So if you have a cube root is for a 1/3 power. So, and then there are others. So that's how the fraction works if it's not just a 1/2 or a 1/3. So 3/2 power is a square root of x to the third, which at this point we should probably simplify too, but I ran out of space. For the last problem, that was F and then Q. This one is only half sneaky because the idea is, can we write powers of x? We can write powers of x on this one. So this one only counts as being half sneaky. If we multiply this out, we get 9x squared minus 6x plus 1. And then we can q prime 18x minus 6. At the time that we did these problems, we had talked about the chain rule. So maybe, so some of you said, I'm gonna use the chain rule on this, which is also acceptable. You might have chain ruled it by saying it's 2 times 3x minus 1. One of the things that you, to the first, 2 minus 1 is equal to 2 only works in billionaire math. But we have to use the chain rule because the stuff inside is 3x minus 1. The derivative of 3x minus 1 is 3. This needs to be cleaned up. So you would clean that up and write 6 times 3x minus 1. Which is the same as 18x minus 6. So if you were off by a factor of 3, it's because you forgot the chain rule. So the whole point of these problems were that you could use nx to the n minus 1 all the way through. So that was my intention. Part D, that was pretty sneaky, kind of a jerk move on my part. Part F was only half sneaky because we did have the chain rule, but we didn't have to use the chain rule. But if you do use the chain rule, you have to do it correctly. Any questions? In 2, I guess there was only one part. I didn't need to call it A. We had y equals square root of x at x naught equals 4. So here I'm translating it to go through the problem. I wrote y equals square root of x because I didn't want to use the equation editor. I don't know, sometimes I'm lazy. Plus, I wanted to make it look like the problem that we already had. So this is an x to the 1/4, or sorry, x to the 1/2. And when I say at x equals 4, that means I'm saying x naught is 4. The pieces that we need to put together, we need to get y naught. Y naught is just the function square roots, is this the square root of x naught, which is 2. So that gives us a point of x 4 and y naught 2. We're trying to write the equation of a line. I need a point and a slope. Plug in to get the point because I only gave you half. Being able to, for me, if I find the 4, 2, and I can see that you got that, and you're saying that this is the point, this is the thing you're thinking, I need a point, here's a point. Whatever else went in the problem, you got a point for finding the point. It seemed appropriate. For the slope, we need the derivative. So we're going to read this as at x to the 1/2 power. And so that tells us that y prime is 1/2 x to the minus 1/2. And then we plug in 4. I want y prime at 4 for the slope. So the slope is 1/2 times, I'm going to write it out. I need y prime at 4. So 1/2 times 4 to the minus 1/2. Here we have to take read our minus 1/2 power and go backwards because we want to plug stuff in. So it's a 4 to the minus 1/2 is a 1 over square root of 4. So it's a 1/2 times 1 over the square root of 4. Square root of 4 is 2, so we get 1/4. That's our slope that we could put together in the point slope equation. The easiest one to get. We would write y equals y naught plus m times x minus x naught. Some of you went all the way to slope intercept, just kind of multiplying all this out. 2 minus 1 is 1. So that would also be acceptable. No one wrote standard form because I guess standard form is just not that popular. If you don't want to be just like all the Brittany just wannabes, then write your equations in standard form. And finally, the problem 3 was the same thing. I just didn't make you do any calculations to get at the stuff. In problem 3, once again, I called it A. We have f of 3 is equal to 7, and f prime of 3 is equal to -2. We can take this information, f of 3 is equal to 7. That gives us a point of 3, 7. F prime of 3 is -2, gives us a slope of -2. So I can put this into a linear, the equation of a tangent line as 7 minus 2 times x minus 3. Then to approximate f of 3.1, I could just plug the 3.1 into the tangent line. (3.1 minus 3 is 0.1 times 2 is 0.2. 7 minus 0.2 is 6.8. Any questions? Is that okay? So as far as scoring goes, each of these parts was worth 4 points. So there's 8 parts, so 32 points total. I started off just zeroing out anything incorrect for any reason. Then I started feeling bad about that. Stupid empathy always getting in the way of just cold, rational decisions. So I started putting points back on. So if you have like a X crossed out, then a number, then crossed out, then another number, I probably like, no, that seems kind of fucked up for taking off all the points for that. Any questions on scoring? So I did put up the on the Canvas version where you can go enter in your answers. The combination of this, the reason I don't feel too bad about like just dropping all the answers and then asking you to go find it out, is that this is going to be the difference between whether you just put the answers in onto Canvas to score more points or whether you use the answers that you've been given to fix the things that are broken. That's what you need to do right now. Your job is to fix the things that are broken. Some of you don't need to fix anything. You've got 32s. I'm not talking to you clearly. So take your opportunity to fix the things that are broken. If all you're doing is going to go take these and put them into Canvas, then expect a similar thing to happen next time. And then when we get to the end of the semester, nothing's going to get fixed. Does that make sense? I really don't care what you got on this one. So I don't care if you straight up got a 0. The best that you could do is just write your name at the top, say, I don't know what I'm doing. I'm not ready for this, Michael. That's okay. Shit happens. Sometimes that's like literally why you're here, by the way. That's why I don't want to be a dick about it. It's like, oh, I don't know how to do math, Michael. I know. That's why you're here. That's why those of you like with the quotient rule, Michael, what are you doing here? Why are you here? Not on you, on someone else. Say, you have to take this class. And you're like, oh, but I did this. No, you have to take this class. And you're like, oh, fine. Which is just playing the game. I understand. Any questions? Comments? Deep thoughts? All right, the new set of homework has come up. It's going to be that first part of chapter 3, shortcuts to differentiation, chain rule, product rule, and quotient rule, which we haven't talked about, which I'll talk about on Monday, if I remember to, and exponential and trigonometric functions. And then we'll add to that stuff next week and finish out chapter 3. All right, so that's it for today. I will see you all on tomorrow. If you did not sign in or get your tests or practice tests returned, I have them up here. Mark? Mark?
It's actually not one bad. We just got like our first lab project, so we got like paired up partners. Figures it out. Huh? So apparently we're just not able to, it's just like. Taking my time.